So let's look at a problem where we have to answer Q queries on an R cross C matrix, and each query is going to give us start row, start column, end row, end column, and we have to give the sum of all the submatrix elements in this given range. So if we take one of the examples, let's say here row numbers are numbered 1 to n, so 1 to r, and columns are numbered 1 to c. So let's see first query. If I say the start cell is this, which has 5 elements, so it is 2, 3, that's the start row is 2, start column is 3. And if I go to end row and end column as 3, 6, so end row is 3 and column is 6. So we are essentially talking about this particular submatrix. So start row, start column is like top left, and end row, end column is like bottom right of the submatrix. So we have to give sum of this submatrix. So if we really look at the sum, 5 plus 3, 8, 5, 13, 13 minus 9 is 4, 4 minus 8 is minus 4, minus 4 minus 11 is minus 15, minus 15 plus 6 is minus 9, and minus 9 plus 6 is minus 3. So that is the sum we are looking for. Let me just cross verify. 6, 6, 12, 12, 5, 12 and 10, 22, 22 and 3, 25, 25 minus 20 is 5, 5 minus 8 is 3, minus 3. Yeah. So this is first submatrix sum, or first query's answer, we can say. So this is coming out to be minus 3. Just to understand problem clearly, I'm writing few more that you can work out yourself. So if I give you as start row, start column as 1, 1, it starts here, and end row, end column as 3, 5. So just work out what sum you are going to get. It is 3, 5. Same way, if we take start row, start column as 3, 1, starting here, and end row, end column as 4, 5, then what is the sum you are getting? And same way, if I give you start row, start column as 1, 2, start row, start column is 1, 2, and end row, end column, I can make it as 4, 4. So for this matrix, just pause the video for a moment, work out these answers just to understand the problem clearly and problem better. Yeah, guys, don't look for the answers right now. I'm not going to reveal it. So make sure that you are working out the answers yourself. Just fill in this table, only then it makes a point to move forward and understand the logic and intuition behind how do we solve it efficiently. So just pause the video for 5 minutes time and complete all these sum values. Now for each query, we can solve this problem just by reading the query and looping over all the elements in that submatrix range. So our first solution that we can certainly think of is, you can say, brute force. And brute force solution wise is for each query. So for each query, what we will do, we will read these 4 values, read SR, SC, ER, and EC. So we read 4 values. Then we declare a sum, which we can say, let's say long sum. So in C++, we'll have long as a data type. Java will have just long. So we take that sum. Now, if you see, we have to essentially go from, in this example, 2, 3, go to second row, third column. From here, we have to start and we have to go up to 3, 6. So 3, 6 is here. So essentially, we'll have a loop for I starting at SR, ending at ER. Same way for J, starting at SC, start column, and ending at end column. And what we will have is S plus is equal to, we will have, let's say matrix is M, so M of IJ. And finally, once we have calculated the sum, we can just print the sum. We can just call it write or print. So this is the pseudocode for answering one query, and we have to do it for each query. Now, if we go with this approach, outer loop, which we are running for each query, will run q times. And we can see that inner loop is going to run for entire submatrix that we are taking. Now, in worst case, author of the problem can give us queries which are on entire matrix. So there can be R into C. This worst case, these two loops can go R into C. So overall complexity becomes Q into R into C. So this is our overall time complexity. And in doing so, we are not taking any extra space. We are just using one sum variable to ing variable. So space complexity becomes big of 1. Now, in this case, if our R and C constraints wise, if R and C are 10 to the power 3 and number of queries are 10 to the power 4, or let's say 10 to the power 6, then certainly this complexity is not going to be accepted, because this will eventually make it as 10 to the power 6 into 10 to the power 3 into 10 to the power 3. So this is the maximum values I'm putting. So this is 10 to the power 12, which will essentially give us TLE. So we need to come up with a better and efficient logic for solving this problem. Now think about it, how we can go and solve this problem efficiently. Now, since this is a queries question, and most of the times when we have multiple queries to answer on a fixed data set, then it always helps to pre-compute. So we will think in pre-compute direction. And second thing is, since this is sum queries, we have a concept called prefix sum in array, which helps us. If we have prefix sum of an array, it helps us get sum of any range in the array efficiently. So these two concepts we will try to apply. We'll think in this direction and see, can we solve this problem in a faster way? Can we answer each of the query in a faster fashion rather than every time doing like a brute force?